Today, we're going to learn how to write the equation of a polynomial function if we know the zeros and the end behavior. So sometimes we'll be given that information directly, and sometimes we will be given it in a graph. So the steps for writing the equation are first to find the zeros of the function and their multiplicities. The second thing we'll need to do is take that information to help us write the factors associated with each zero and determine if we're going to have an even or odd exponent based on the multiplicities. Finally, we'll find the a value of the function by plugging in another point and solving for a, or sometimes we're just given the end behavior and we can use that. So let's start with our first example. In this first example, we're specifically told that we have 3 different zeros and we're given the multiplicity on each one. So the next thing I'm going to do is write my possible function f of x. I'm going to leave a little bit of space for my a value, and I'm going to write x, or x minus 0, with a multiplicity of 2. My next zero is x equals 3, negative 3, so I get x plus 3 as my factor with a multiplicity of 1, which you can write or not. And then lastly, we have x equals 5 with a multiplicity of 1, so my factor is x minus 5 to the 1 power. Now, I'm not going to write the 1 power, and I'm not going to leave this blank here. I want to find an a value that I can plug in. So the next piece of information I'm given is that as x goes to infinity, meaning as we move to the right of the graph, it says that the function is decreasing to the right. And this tells me that I have a negative a value. So I can choose any negative a value, and I'm going to choose negative 1. You could have chosen negative 2 or negative 3. There's lots of different functions that have these features. So my final answer here would just be f of x. I'm going to write the negative 1 as just a negative sign. X minus 0 is just x squared. X plus 3 to the 1 power is just x plus 3. And x minus 5 to the 1 power is just x minus 5. So this is one possible function that has all of these features. A 0 of 0 with a multiplicity of 2. A 0 of negative 3 with a multiplicity of 1. And a 0 of 5 with a multiplicity of 1. And now we're going to try an example with a graph. So in this case, we're being given a cubic function represented in a graph below, and we can see that there are 2 zeros, one here and one here. We'll also notice that this one crosses through the x-axis, which means we have an odd multiplicity, and this one bounces away, which means we'll have an even multiplicity. You'll also remember that a cubic function is going to have all the multiplicities add up to 3. So I am going to choose that for my first zero, x equals negative 1, I need an odd multiplicity. And for my second zero, x equals 3, I need an even multiplicity. And I need those numbers to add up to 3. So I'm going to choose an odd multiplicity of 1 and an even multiplicity of 2, so that these numbers add up to my cubic function that has 3 linear factors, one that's repeated. So now that I have my zeros and my multiplicities, I'm going to start writing my equation. So my equation is in the form g of x equals some a value times x plus 1 to the first power times x minus 3 to the second power. And I'm choosing that x minus 3 to the second power because I have a multiplicity of 2, and the x plus 1 is just to the first power because it has a multiplicity of 1. The next thing I need to do is find a good point on my graph, and the only really good one I see here is 1, 4, to plug in to find my a value. So I'm going to plug in x is 1 and g of x, or y, is 4. So 4 equals my a value, and 1 for x So I have an a value that I don't know. I have 1 plus 1 and 1 minus 3 squared. And now I'm just going to solve. 4 equals a times 2 times my negative 2 squared. Exponents are next. 4 equals a times 2 times 4. 4 equals 8a. Remember to multiply that and put it in front. And then when we divide by 8, we get a is 4/8 or 1/2. So finally, I just write my function. I'm going to replace that a with a 1/2 and write the rest from here exactly as I had it before. X plus 1 and x minus 3 squared. We'll do one more example. In this situation, I have a quartic function, which means that my multiplicities need to add up to 4. Well, I notice that I have 2 zeros here. One at -4, which is even, so I know I have a bounce. Which is a bounce, so I know it's even. And then another one at 3. So here, my zeros are x equals -4 with an even multiplicity, and x equals 3 also with an even multiplicity. So in order for those multiplicities to add to 4, they must both be 2. Next, I'm going to write my equation with my unknown a value, x plus 4 squared times x minus 3 squared. Next, I need to find a nice point to plug in for x and y that's not one of the zeros. And the only option I have is here. When x is 0, we know that y is 48. So I'm going to plug in a 48 here and a 0 here. And I'm going to solve for a, just like before. Plus 4 squared, 0 minus 3 squared. So I have 48 equals a times 4 squared times -3 squared. 48 gives me a times 16 times 9. That gives me 48 equals a times 144. And when I divide by 144, I get that a is 48 over 144. And if you need a calculator to help you out, that's fine. That will give you 1/3. So my final equation for this function would be g of x equals 1/3. And then I take the rest from where I had it before. X plus 4 squared times x minus 3 squared. Don't forget to fill out your survey, and we will do some practice with this tomorrow.